So, arc length with like radius times radians, and then like angular speed and linear speed.
Okay. Do you have a specific problem?
Well, first I was just wondering if you could kind of talk about angular speed versus linear speed.
I didn't hear what you said. Say again.
I was hoping you could talk about angular speed versus linear speed.
Okay.
Like,
Sure. Sure. Let's talk about linear speed first of all.
Okay.
If that's a road, and I'm going along the road, that's linear speed.
Okay.
Okay. Miles per hour, meters per second. It's all kinds of different units, but linear speed is some number of linear units per some time frame. Angular speed, let's say you have a wheel rotating, and it's rotating in this direction, and it rotates once per second.
Yeah.
That's angular speed.
Okay.
Okay. Now, how do you convert angular speed to linear speed? Well, notice that if this is a wheel attached to a vehicle, and there's another wheel over there, and you got a vehicle like that. I'm a terrible artist, unfortunately.
Yeah.
Every time that, assuming these two wheels are the same size, every time that wheel makes a rotation of one rotation per second, let's say, how far forward does that vehicle go? And I've made forward to the left here, I apologize. But since I made the wheel rotate counterclockwise, I figured I had to make it go to the left.
It will go the circumference.
Right. Let's say that radius is 7 of that wheel. So how far does the vehicle go in 1 second? We got a wheel that's making 1 revolution per 1 second. So what's the speed of that vehicle? What's the circumference of that wheel? You're on the right track.
Yeah, 2 pi r.
Okay, so that's 14 pi. That's the distance the vehicle goes in 1 second. In other words, whatever the circumference of those wheels are. Now, that's an interesting point, because think about the size of wheels. Have you ever seen these monster trucks?
Yeah.
Well, obviously, if you had a bigger wheel and you were still able to go 1 revolution per second, the radius on this bigger wheel is 9, let's say. Well, that vehicle moves 18 pi per second forward.
Yeah.
So as long as you can force that wheel to do a certain number of revolutions per second, the bigger the wheel, the faster you move.
Yeah.
And the smaller the wheel, the smaller you move.
Okay.
Okay? So that's my basic explanation and understanding. I can give you a specific problem, if you like, that's actually quite instructive.
That would be good.
Okay, let me give it to you. I love this problem. It's hard, but not really. It's what relates angular and linear speed.
Okay.
Alright, so we got Albert Juarez's truck has wheels that are 36 inches in diameter.
Okay.
If the wheels are rotating at 630 RPM, which means revolutions per minute, find the truck's speed in miles per hour. And this is a very typical problem that you have. Okay? So, the secret to this problem is getting your units to cancel. Okay, here's what we start with. 630 revolutions per 1 minute. That's what RPM means.
Yeah.
And what we want to end up with is the units of miles per hour. Okay? So we got to convert this minutes to hours, and we got to somehow convert revolutions to miles. Well, the first thing to convert is the minutes. 60 minutes per 1 hour.
Yeah.
Minutes cancel, you got hours in the denominator, and that's where you want it. Now, the next part is the hard part. 2 pi radians per 1 revolution. First of all, and when I say that's the hard part, that's the part everybody would have trouble with. Now, do you understand that conversion factor? Do you see why it's 2 pi radians per 1 revolution?
Yes.
Okay. And the revolutions cancel. Now we got radians per hour. Well, can you hear me? Okay.
Yeah, but I don't understand why it isn't the circumference 2 pi radian. Not 2 pi radian.
It's radians. In other words, if you go completely around a circle, that's 360 degrees, which is 2 pi radians. Now, the next part will make more sense of this conversion. This is not an easy one, but in this case, it's 18 inches per 1 radian. Where do I get that? Well, you have to kind of go back to the definition of a radian. What's a radian? A radian is 1 radius. In other words, let's look at a circle. Okay?
Yeah.
That's 1 radian right there. Why is it 1 radian? Because the radius is equal to that arc length. That's why that's 1 radian. And the full circumference is 2 pi times the radius. So if the radius were 1, you'd have a circumference of 2 pi radians. So it's 2 pi radians every time that thing makes a revolution.
Okay.
Okay? Now, the next part's harder to understand. That's R, but that's also R. The measurement of that arc length is the same as the radius. And that's 1 radian. So it's the radius per 1 radian. And the radius in this case is 18 inches because the wheel was 36 inches in diameter. Okay? These are the two toughest steps for sure in these kind of problems. And if you can get those two steps, then the rest of it's easy. Those are the two tough steps. Now, there's still more to go. There's times 1 foot per 12 inches. Notice now the inches go away. The radians have gone away. And at the moment we have feet per hour. Well, there's also 1 mile per 50 to 80 feet. Now the feet go away. And we end up with miles per hour. And remember, that's the secret, is to end up with the units you want. Is all I have substituted in here is 5 or 6 conversion factors. In other words, I'm starting with 630 revolutions per minute, and I'm ending up with some number of miles per hour. Well, if I multiply all the numbers, in other words, I'm going to multiply 630 times 60 times 2 pi times 18, divide that by 12, and divide that by 5280. What you get? 67 miles per hour.
I understand the conversion and all that, but could you talk about that circle on the top left and radius?
Yes.
Radius?
Yes. This is not something that's that easily understood, but it's worth understanding it. And that is, what is a radian? That angle right there. If theta equals 1 radian, then the measurement of arc AB, you know what that means, equals the radius. So whatever the radius is, let's say the radius was 2, then the measurement of AB would be 2. If the radius was 5, the measurement of AB would be 5. So theta is whatever angle is necessary such that the radius is equal to that arc measurements. And that angle ends up being approximately 57 degrees. What we know is that the entire circle, which we know is 360 degrees, is always equal to 2 pi radians. So that's an equivalent conversion factor. Pi is equal to 180 degrees, pi radians. Okay, now I've drawn that closer to a 90-degree angle. I didn't intend that. It's if I remember right, about 57 degrees. If you multiply 57 degrees times 2 pi, you will get 360 degrees.
Okay. And so on a problem like that, will they always either give you the degree, radius, the radius, or the radian, and then you just have to solve?
Not necessarily. I've seen this problem given in lots of different ways. This is the key formula. If I was going to say there's a key formula, let me write it a little nicer. We got 630 revolutions per minute. Multiplying that by 60 minutes per hour. Multiplying that by 2 pi radians per revolution. You get that, right? Every time that thing does one revolution, that's 360 degrees, which is 2 pi radians.
Okay.
And then it's 18 inches per radian. In other words, the radius of that wheel is 18 inches. Well, that's what a radian is the radius. And then I'm multiplying that by 1 foot per 12 inches, multiplying that by 1 mile per 5280 feet. The whole goal is to end up with some numbers of miles per hour. Well, if I start at the beginning, minutes cancel. Hold on. Revs cancel. Radians cancel. Inches cancel. Feet cancel. And I'm left with miles per hour. Now all I got to do is multiply all the numerators together and divide by all the denominators. That's how I get 67 miles per hour. Now, you ask a very good question. Are they always going to give you all of this information on the left side of the equation? And the answer is no. In other words, this problem could just as easily have been asked as, the car is going 67 miles per hour. What's the diameter of the wheels?
Yeah, and so actually the one that I have in front of me is it's going 65 miles per hour. The diameter is 2.5 feet, and then what is the number of revolutions per minute?
Okay, but notice that everything, in other words, in my problem, that was defined, that was defined, that we knew, that we knew, that we knew, that we knew. We were trying to solve for the final speed. Well, if they give you the final speed, then you could solve for any of these other variables, right? In other words, you know that A times B times C times D times E times F is equal to that miles per hour. Well, if they give you the miles per hour, but they want to calculate revolutions per minute, then make this your variable. And all you have to do is solve for it. It's the same general equation. In other words, here, let me be a little more specific. The general equation is this. A RPM, that's revolutions per minute, times 60 minutes per 1 hour, that never changes. This never changes, 2 pi radians per 1 revolution. This changes, that's the radius per 1 radian. It's not accidental that they call it a radian. It's meant to be the same as radius, okay? Times, this never changes, 1 foot per 12 inches. And this never changes, 1 mile per 1 hour, or per 5280. 5280. 1 mile per 5280 feet. That equals the miles per hour. So, they're never going to make this the variable. They're never going to make that the variable. Well, actually, the radius per radians is a variable. In other words, that they could make that the variable. We always have 2 pi per 1 revolution. That's a fixture. So is 60 minutes per hour. So is 1 foot per 12 inches. So is 1 mile per 5280 feet. So the only variables here can be the revolutions per minute, the radius per 1 radian, and the miles per hour. So in my problem, I gave you everything except miles per hour. But they could certainly ask you any variation of this problem. In other words, they might give you miles per hour and make you solve for the revolutions per minute. Shouldn't matter. What we have here is A times B times C times D times E times F equals MPH. Well, if they give you A through F, then you can calculate MPH. If they give you MPH and B through F, then you can calculate A. In other words, as long as there's only one unknown there, you're going to be able to solve this equation. And they always give it to you so that there's only one unknown. In other words, the problem I gave to you, the unknown was the miles per hour. But most of the problems that my students tend to give to me, the unknown tends to be either the revolutions per minute or the length of the radius. That's an unknown also. But there's only 3 possible unknowns, and that's the revolutions per minute, the radius length of the wheel, and the miles per hour. So whatever problem they give you, whatever they want is going to be one of those 3 things. So it's not hard to do the algebra. What's hard is remembering that general formula. Because the 2 parts that are particularly difficult is the 2 pi radians per revolution and 1 radius per radian. And by that I mean a length of the radius. That's not 1 radius per radian, it's 18 inches per radian, or 9 inches, or whatever the radius of the wheel is. So what I have circled is what you might have to solve for. Nothing else you will. You won't have to solve for 60 minutes per hour. You don't have to solve for 1 foot per 12 inches or 1 mile per 5280 feet. But they might ask you either the revolutions or the radius or the miles per hour. That's the only thing they're ever going to ask for, is those 3 things. And in order to solve for any of those, no matter how they ask the question, you got to know this formula right there. So that's what you want to memorize. In other words, the best problem you can possibly do to understand this problem is the one I gave you, where you're solving for the miles per hour. Because that forces you to lay it out as 6 different things multiplied together. And once you know how to do this problem, then you can do any of the problems they give you. If they give you the miles per hour and ask you to solve for the RPMs, that's just algebra. You're solving for this instead of the final thing on the right side of the equation. That's no problem. Or they might ask you to solve for the diameter of the wheel. So you'd solve for the radius and multiply it by 2. And that'd be the diameter.
So I I have an appointment with you tomorrow, so I think, well, I just have to practice problems so we can work on those.
Okay.
And make sure I do it correctly.
Sounds good. Max, I'll talk to you tomorrow night.
Okay.